The world's planetary defense infrastructure finds itself operating at an unprecedented state of heightened vigilance as interstellar object 3I/Atlas C/2025N1 continues to confound astronomers, challenge long-held assumptions, and disrupt the very models used to understand celestial mechanics. What began as a routine observational curiosity has rapidly escalated into one of the most significant astronomical events of the decade, compelling scientists, researchers, and global agencies to reconsider what is possible within our cosmic neighborhood. In a highly unusual and consequential move, the UN-endorsed International Asteroid Warning Network, IAWN, officially selected 3I/Atlas for inclusion in its respected comet astrometry campaign. This designation alone has intensified international attention, as IWN rarely elevates newly discovered objects to such status unless they display properties so unusual that existing tracking frameworks struggle to explain them. The decision signals not only heightened scientific interest, but also a recognition that the global community might be confronting a phenomenon that sits far outside the boundaries of conventional comet behavior. 3I/Atlas is only the third confirmed interstellar object ever observed entering our solar system, following 1I/Oumuamua and 2I/Borisov, and yet it behaves in ways that surprise even those who believed they had already witnessed the limits of cosmic strangeness. While most comets shed dust and gas that create a tail streaming away from the sun due to solar radiation pressure, this object displays a luminous anti-tail, a baffling stream of particulate material extending toward the sun rather than away from it. This optical and physical anomaly has provoked intense debate and discussion among experts, many of whom confess that no accepted model fully accounts for such behavior. Some have proposed exotic gravitational interactions or unusual particle compositions, while others observe that the object's luminous configuration changes incrementally in ways that suggest unknown forces may be acting upon it. The fact that the anti-tail persists even as the object accelerates along a trajectory inconsistent with purely natural outgassing has further complicated attempts to model its motion using standard orbital mechanics. IAWN officials, acknowledging the complexity of the situation, have emphasized that comets, especially those of interstellar origin, pose exceptional challenges for accurate astrometric measurement. Small deviations in light reflection, jetting activity, or dust emission can introduce substantial errors in trajectory prediction. Yet in the case of 3I/Atlas, the difficulties appear magnified many times beyond what is normally encountered. By adding the object to its comet astrometry campaign, IWN aims to refine its measurements with unprecedented precision, improve predictive models that have so far shown significant residual inconsistencies, and test the observational community's capacity to extract reliable astrometry from an object that might not be behaving like a natural comet at all. Their public statement, which diplomatically notes the campaign's purpose as an effort to exercise the capability of the observing community to extract accurate astrometry, is widely interpreted as a subtle acknowledgement that 3I/Atlas could be forcing the scientific world to push beyond the limits of current technology and analytical tools. Amid this atmosphere of uncertainty and curiosity, Harvard astrophysicist Dr. Avi Loeb has once again stepped into the international spotlight. Long known for challenging orthodox interpretations of interstellar anomalies, Loeb has openly suggested that the possibility of artificial origin must be taken seriously. His earlier hypothesis that Oumuamua might have been a piece of alien technology was dismissed by many mainstream scientists at the time, yet it is now receiving renewed attention as 3I/Atlas continues to exhibit behavior that resists natural explanation. Loeb estimates that there is approximately a 40% likelihood that the object could be an engineered structure or device, perhaps even a type of extraterrestrial mothership deploying smaller reconnaissance probes into various regions of the solar system. Such a claim has predictably ignited controversy, with critics accusing Loeb of sensationalism and arguing that extraordinary claims require extraordinarily robust evidence. Nevertheless, the persistence and peculiarity of the object's motion have given his theories more traction than they might otherwise have received. NASA, maintaining a cautious stance, has publicly reiterated its belief that 3I/Atlas is a comet and nothing more. Yet observers note that the agency's tone has softened in recent weeks. Instead of dismissing unconventional theories outright, spokespeople emphasize the necessity of continued observation, expanded data collection, and collaboration with international partners. This shift in tone may reflect growing unease within the scientific community as new data pours in from observatories around the world. Small but consistent deviations from predicted trajectories, fluctuating luminosity patterns that do not match standard comet behavior, and the persistent anti-tail have created a sense that something about 3I/Atlas defies classification. While NASA stops short of embracing exotic explanations, its increasing willingness to describe the object as poorly understood and dynamically unusual is being read by many as an implicit acknowledgement that traditional models are not providing sufficient answers. As telescopes, radar arrays, and spaceborne sensors continue to focus on the object, researchers confront a growing list of uncertainties. Why does 3I/Atlas radiate energy in irregular pulses? What accounts for its unusual rotational dynamics, which appear to shift in response to forces that cannot be easily identified? Why does it exhibit such a stable anti-tail configuration even under intense solar radiation, when any natural comet would undergo substantial morphological changes? And perhaps most troubling of all, why does its trajectory appear to exhibit tiny but measurable course adjustments that are not consistent with random outgassing or natural torques? Each new observation brings both clarity and complication, as if the object itself were designed to challenge human understanding. Some theorists argue that the object may be composed of unfamiliar interstellar materials that respond differently to solar radiation and gravitational fields. Others propose that 3I/Atlas could be a fragment from a shattered exoplanetary body whose structural composition allows for unique light-scattering behavior. Yet even these explanations struggle to account for the full range of anomalies. The idea of artificial origin, however controversial, persists because it satisfies certain behavioral aspects that natural models cannot yet reconcile. Loeb, for his part, insists that exploring such hypotheses is not pseudoscience, but a necessary component of intellectual honesty in the face of unexplained data. The public has become increasingly captivated by the unfolding story. Social media platforms amplify each new observation. Sensational headlines speculate about alien craft, and amateur astronomers contribute their own findings, some of which reveal features that appear and disappear unpredictably. Meanwhile, professional researchers urge restraint while admitting that they too are surprised daily by the object's unpredictable characteristics. Governments and scientific institutions walk a careful line between transparency and caution, seeking to avoid public panic while acknowledging that the object warrants careful and continuous monitoring. Behind the scenes, the planetary defense community is quietly assessing whether 3I/Atlas poses any conceivable risk to Earth or other bodies in the solar system. Current projections do not indicate a collision trajectory, but the residual uncertainty in its orbital solution is larger than scientists would prefer. If the object's motion cannot be reliably predicted, long-term assessments become inherently tentative. This uncertainty has deep implications for planetary defense preparedness, especially if future interstellar objects exhibit similar unpredictable behavior. As researchers refine their instruments, analyze evolving data streams, and develop new computational models to simulate the object's path, they also grapple with the philosophical implications of what they may be observing. If 3I/Atlas behaves unlike any known natural comet, then the scientific community must confront the possibility that humanity is encountering a type of object never before documented. Whether that implies technological origin, an unprecedented natural process, or an interstellar phenomenon beyond current understanding remains an open question, one that drives continued observation, debate, and speculation. In the coming months, the collaborative efforts of astronomers, astrophysicists, data scientists, and global agencies will likely lead to clearer insights, though perhaps not final answers. The mystery of 3I/Atlas illustrates how little we still know about the vastness of interstellar space and the potential diversity of objects that traverse it. For now, the world watches with equal parts excitement and apprehension as the enigmatic visitor continues its journey through the solar system, challenging established science and inviting humanity to reconsider its place in a universe that still harbors countless unknowns.